I've been fishing all my life, and I started bass fishing in the 7th grade. In the 9th grade, I started fishing competitively. As I got more into competitive fishing, I learned about these special reels called bait casting reels or open face. Now, it took me about 3 months to actually learn how to use it, and I really had no idea about the math behind it, or how the different versions of these reels really affected my fishing, so I used them all interchangeably. What I didn't know is that because of certain factors like the gear ratio, it had a bigger effect on my fishing than I thought it would. Like I said, this is a bait casting reel, and there are hundreds of different models on the market. And there are several different gear ratios that these different reels have. For example, this one says 6.3 to 1, and for the longest time I had no idea what this meant. I thought it had something to do with just the number of gears inside, and it didn't have anything to do with the speed of the reel or how it felt. So what this means is that with every one rotation of the outside handle, the inside spool rotates 6.3 times. And after I figured out what this meant, I looked at my reels and realized that I had different gear ratios that I was using for the same technique, and thought that maybe because of this, I was catching less fish than I could have been. On the table, I have two of my favorite types of lures, a deep water crankbait and a shallow water crankbait. Obviously, there's a difference between these, as one is made for deep water and one is made for shallow water. But what's really important with these is to have the right gear ratio for the lure that you're using. For example, the deep running crankbaits, they need about a 5.3 to 5.4 to 1 gear ratio, while the shallow crankbaits can use a 6.3 or 6.4 to 1 gear ratio. And I had no idea what this meant for the longest time. I'd seen it online but thought it really didn't matter. But using a pre-calculus concept, I can truly understand, and you can too, why different fishing reels are used for different techniques. Before I talk about the math behind the reels, it's important to understand that the slower a lure is reeled back in, the deeper it will dive. The two pre-calculus concepts I'll be explaining are angular speed and linear speed. Angular speed is how fast the central angle measure changes. For example, in this reel, the angular speed is the measure of how fast the central angle of the spool changes. The formula we can use to find this is 2 pi times the number of revolutions. And the units are going to be in radians per time, but be consistent. For example, 1 unit would be radians per minute. This is another way of thinking of it. Angular speed could be the arc length divided by the time. I find that on average I rotate the handle about 108 times per minute. If I go any slower, I'll just go back to my normal speed, and if I go any higher, I run the risk of getting tendinitis. So if I multiply the number of rotations on the outside handle by the number of the inside, I can find the revolutions per minute. So I get 680.4 and 583.2. And if I multiply both of these by 2 pi, I can find the radians per minute. So for the 6.3 ratio reel, I get 4,275.1 radians per minute, and for the 5.4 to 1 ratio reel, I get 3,644.4 radians per minute. We found the angular speed, which is good, and we see that they're obviously different. But it's just angular speed, which means it's kind of hard to interpret, so we should find the linear speed too. Now that we know our angular speed, we can find our linear speed, which will tell us how fast our line is moving, and in turn how fast our bait is moving. To find linear speed is easy. You take the angular speed and multiply it times the radius. In this case, the radius of the spool is 7/16 of an inch, or 0.4375 inches. So we multiply the angular speed by the radius, and we get 1,870.4 inches per minute and 1,603.2 inches per minute, which is pretty significant when it comes to fishing. So I converted the previous linear speed from inches per minute to feet per minute, and I determined that about the maximum length I can cast is 50 feet. So if I make a 50-foot cast with a 6.3 to 1 gear ratio reel, I can reel it in about 19.2 seconds. And if I do the same 50-foot cast with a 5.4 to 1 gear ratio reel, I can reel it in about 22.5 seconds. And because of this, that extra 3 seconds really does make a big difference. I can reel comfortably and know which reel to use and have my bait dive down to the proper depth. So thanks to pre-cal concepts, I've learned just how important it is to use the right reel and why this is.